Hi, welcome to the video solution for past papers. This is Edexcel IAL Physics, Unit 1, January 2020. So let's start. Question number 1. Which of the following quantities has the SI base units kilogram m square s minus 3? So if you see, this is the SI base unit and these are the quantity. The one option is you memorize the SI base units of various quantities, but if you see that the force is Newton, and Newton is kg meter s minus 2, and we have work done, which is joule, and joule is kg meter square s minus 2. The reason is, in the definition of work, one additional displacement or distance involved, like W is equal to F into D or F into S. Additional meter is there, so you have a meter square, and now you have a power. So power is, which is work done upon time, and the work done is joule, and joule is this, and divided by time. So additional time is coming. That means if you work out the SI base unit, so it will be kg meter square s minus 3. That means this is the unit of power. So your option should be C. Question number 2. Which of the following statements describe the gravitational field strength acting on a body at a point? Gravitational field strength. If you see the definition, or if you want to know the definition, you must know the formula for gravitational field strength. And formula for gravitational field strength is G is equal to F upon M. This is another way to write G is equal to W upon M. W upon M, meaning from W is equal to mg. So where W is gravitational force or F is gravitational force. So gravitational force per unit length, no. Gravitational force per unit mass, B should be your answer. So gravitational potential energy, there's nothing to do with the energy because this is a gravitational field strength, and gravitational C and D cannot be your option. You will have to choose between A and B. So B should be your option. Force per unit mass, or you say the gravitational force per unit mass. Question number 3. The diagram below show the velocity of an object before and after a force is applied. The magnitude of the velocity did not change. Which of the following arrows represent the direction of change in the velocity? Remember, this statement is really important because they are saying that the magnitude of the velocity is not changing. That means the force is not applying along the direction of the velocity or direction of the motion. Because if a particle is moving, suppose rightward, and force is also applied in the same direction, like F, then this F will cause change in magnitude. If a force applied in opposite direction, like F dash, then this F dash will cause a decrease in the speed. But if a force applied something like this, F double dash, then this force is perpendicular to the direction of the velocity, direction of the motion. So this force will will not change the magnitude of the velocity, but it change only the direction. And direction of the force will always be, it causes change in direction. So change in velocity, in terms of direction. So change in direction will gives us direction of the force. Direction of the force. So if you see what is happening, before the object was moving vertically up, now after force has applied, so object is moving in that direction. So this is your initial velocity v1 and this is your final velocity v2 after force has applied. So if you join these two with the tail to tail, then you realize that the v2 should be something like this. This is your v2 velocity vector. So this will be your change in the velocity, change in the direction, delta v. So force is always applied to change the direction. That means direction of the applied force and the direction of the change in velocity or change in direction will be same. So you see which arrows is in the direction of delta v. Of course it's b. That means force has applied in that direction. That's why velocity, the direction of the velocity has changed that much. So option should be B. Question number 4. A ball of mass m is projected vertically upward and air resistance F acts on the ball at all the time. Which of the following equation would apply to the ball as it is traveling upward? Okay, so a ball is traveling upward. This is the direction of velocity v, moving upward, and air resistance is acting. That means on this ball you can visualize there must be two forces acting on the ball. One is the force acting downward, which is the weight of the ball, and of course there is air resistance, and air resistance always in opposite direction. That means air resistance also acting downward. So this is force F, and there is no other force other than these two. So these two forces are acting on this object and it is moving upward, going upward. So that means due to these two forces, this object is decelerating, and this is the case that you know that when object moves upward, then it decelerates. So the object has an acceleration. So there is a net force acting on this object. So how do you write the formula for net force? Of course, net force will be F plus W will be the net force, F net, and F plus W is mg. Because I am looking at option, we don't have W, so F plus mg is equal to F net, and according to Newton, net force is always ma. So this is the equation for the motion of this type of object, and your option should be D. Question number 5. Two objects P and Q are at the same position at time t equal to 0. The graphs show how the velocity v varies with time t for each object. Okay, so at t equal to 0, both objects were at O. And now which of the following statement describes the position of P and Q at t equal to 4 seconds? So this is t equal to 4 seconds. Now you need to understand these are velocity versus time, not speed time graph. Okay, so these are velocity time graph, and velocity is a vector quantity. So the object P, how do you see the graphs, what object P is doing? So the first graph shows that the object P was moving in one direction with a constant velocity of 1 meter per second for 2 seconds. And after that you see the graph is below the time axis and the velocity is -1. And this -1 velocity is showing that the object is coming back with the same amount of speed at 4. So that means the P has reached its initial position. So you can visualize that this is the particle P at starting position O. It goes for 2 seconds and then return after 2 seconds, so total 4 seconds. This is the meaning of that first graph. Second graph, object Q is the object was first accelerating, but due to some reason its rate of increase in speed is decreasing. That means the rate at which the velocity is increasing, it starts decreasing, and it maybe reaches some at constant speed. So it is continuously moving in one direction. So you cannot have option A because they cannot be at the initial position. P is at initial but not Q. P and Q are at the same distance. No, of course it is gone immediately. P is further from initial position. No, because P has returned but Q is still moving on. Q is further from initial. Yes, so D is your option. Question number 6. A ball is traveling horizontally at a speed of 7 meters per second. The ball hits a vertical wall and rebound along its initial path at a speed of 5. The ball has an acceleration while in contact with the wall. Which of the following expression gives the time of contact t between the ball and the wall? Okay, so this is the wall, and we have a ball traveling rightward with the speed of 7 here meter per second, a meter second inverse, and then the ball hit the wall and then rebound with the speed of 5. So that means it hits and then rebound. It is going back with the speed of 5 meter per second or meter second inverse. And when the ball is in contact with the wall, it has acceleration at 30 meter per second. And remember, what is the situation? Situation is when the ball hits the wall, then wall hits the ball. So ball is experiencing force in that direction. This is the force due to wall. And we have acceleration in the direction of the force. So this 300 meter is also in the same direction. So we have acceleration of 300 meter second minus 2 leftward. Generally, it's all about the momentum situation, and momentum is a vector quantity. So I will consider this right direction as positive and the left direction as negative. It's just arbitrary generally, because right side we choose positive x-axis. So positive direction, negative direction. That means in terms of velocity, this is plus 7 meter per second velocity, this is minus 5 meter per second velocity, and acceleration is also minus 300 meter s minus 1 if you see the direction. And we need to find the time. It's all about impulse. So you know that the force acting on the force F acting on the object F is equal to mv minus mu divided by t. This is general formula, but for us F is equal to minus ma is equal to mv minus mu divided by t. Clearly m gets cancelled and you can interchange t and a. So t is equal to v minus u divided by minus a, meaning v is final velocity, which is minus 5, minus initial velocity minus 7 divided by acceleration 300, which is minus 300. So this is the expression for time. So t is equal to minus 5 minus 7. Yeah, this is the expression. Option is A. Question number 7. Trolley X and Y of masses m and 3m respectively are traveling at the same speed towards each other. The trolleys collide and move off together. So both trolley, it has mass m, this is mass 3m. So heavy and light trolleys. Which of the following statement is correct about the collision or whatever situation is? The forces of xy during collision is greater. Forces of xy is less? No. Option A and B, you cannot, you just ignore immediately. Don't waste time, because remember, in a collision, when two objects collide, we always have same amount of force applied on each object. So force applied by y and force applied by x is always same. According to Newton's third law, action has an equal and opposite reaction, so both forces should be same. So A and B are immediately gone. And the speed of x after the collision is greater, or speed of x after the collision is less? Option is of course D. The reason is, when you have a collision, so of course energy is lost. This is a real life collision. Energy is lost, so definitely mass cannot be changed, but energy is decreasing, energy is lost due to collision. So that means velocity should be less. So it's all about particle x. That means the speed of x should be less than the v, which is the initial one. So option is D. Question number 8. A motor with an efficiency of 68% is used to raise a load of 350 Newton through a height of 25 meter. Which of the following expression gives energy supplied to the motor? So in this case, something is being raised with the help of a motor. Then the gravitational potential energy raised by the motor, this GPE, will be your output, and energy given, energy supplied, will be your input. That means we need to figure out what input is. So formula for efficiency is E is equal to output divided by input in terms of energy. You can say it is input or output, whatever. So output is your gravitational potential energy, which is mgh, and mg is the weight, which is 350 Newton. So I don't need to write mg, it's just w. So 350 times h, and h is 25, divided by input, and input I just write as it is, and equal to efficiency, and efficiency is 0.68, and yeah, it is 68%. So if you rearrange this equation for input, then you will see that your option should be D. So input is equal to 350 times 25 divided by 0.68. Question number 9. A length of a steel wire is fixed at one end. An increasing force is applied to the other end of the wire. The force extension graph for the wire is shown. This is force extension graph, a typical theoretical graph of force extension. Okay, which row of table identifies point P, Q, and R? Remember, if you see these types of graph, the most common question comes from material or strength of material. Generally, a theoretical or typical force extension graph, we consider three important situations or three important points. Number one is the first point, and before this point, we have a straight line and material obeying Hooke's law, and this first point is always called limit of proportionality. This first point is limit of proportionality, meaning at or before proportionality R, at and before R, material obeying Hooke's law. After limit of proportionality, we have a smaller interval in which material behaves elastically, but it is not a straight line. This region is not a straight line, but material is still behaving elastically, but not obeying Hooke's law. Okay, so R is the point where material obeys Hooke's law. And after R till Q, material is not obeying Hooke's law but still behave elastically, and this Q is called elastic limit. And after that we have a point which is called yield point. Yield point. And yield point is the point at and after material behaves plastically, and then we say that we have a large extension with a small increase in force. That's how we define yield point. So this is elastic limit of proportionality, elastic limit, and yield point. So P is your yield point. That means A and B is gone because P cannot be elastic limit. So this is the yield point. And Q is elastic limit. So that means your option is C. Question number 10. Some students were shown a velocity time graph for the motion of an object falling through a liquid. The student suggested possible explanation for the decrease in gradient of the graph. This is velocity time graph, remember, with explanation. Which explanation could be a reason for the gradient of the graph decreasing? So if you see the gradient of the graph is decreasing, that means it has some acceleration, and for falling object through a liquid, and velocity is not constant, that means velocity is decreasing. So the reason is the drag force. Because as velocity increases, the drag force also increases until drag force balance the weight and the upthrust, if you recall. So that means the decrease in the curve of velocity time graph, or gradient, decrease in the gradient of velocity time graph, is existence of drag force. So your option, of course, is A. The drag force is increasing, that's why velocity is decreasing, meaning you have acceleration. There's nothing to do with the gravitational force, okay, meaning weight, because weight stays the same. Gravitational force is the weight, stays the same. The temperature of the liquid is increasing. If temperature increases, then viscosity, if you remember, temperature links with the viscosity. So viscosity, temperature increases, viscosity decreases. So drag force should be, should decrease. And upthrust decreases. Upthrust during motion, upthrust does not change. It also remains same. So gravitational force does not change during motion, upthrust does not change, and temperature cause decrease in the drag force. So your option should be A. Question number 11. A student carried out an experiment to measure the acceleration of free fall G. A ball bearing was released from position A. The time T for ball bearing to fall a distance L was measured. This was repeated for decreasing value of L. Okay, a most typical question, most typical setup of free fall G. Explain how measurement obtained can be used to determine the value of G in meter S minus 2. Your answer should include a sketch on the excess below of the graph that the student would expect to obtain. The idea is, because we are releasing object from rest and it is falling freely, or you can say under gravity. So we will use the concept of the equation, or Newton equation, S is equal to ut plus half at squared, and this S can be replaced with L, the length or height fallen, L. So, and U should be 0, because at start here the ball is U equal to 0. That means your equation turns into L is equal to half at squared. And if you see that, if you rearrange this equation for A, which is acceleration that we need to finding the acceleration, that means A. If you rearrange this equation for A, or make A as a subject, so A would be equal to twice of the L upon T square. Clearly you can see that if you have L divided by T, that means as per graph if I take uh, t square on the y-axis, this is one method. I will show you the other one. So t square on the y-axis, L on the x-axis. So L should be in meter and t square should be in s square. And we always have a straight line. We must have a straight line here, something like this. And gradient of this straight line, gradient of this straight line will be t square over L length. But in our formula, we need L by t square. So we can say that after finding the gradient, acceleration can be found by just 2 multiplied by 1 upon gradient. That's how acceleration can be found. Another method is, you can say, instead of taking t square on the y-axis, you can take L on the y-axis and t square on the x-axis. So L should be in meter and t square should be in s square. In this case, again, you would have a straight line but different gradient, something like it's just a different gradient, and then you will find the gradient. In this case, the gradient will be equal to L by t square. So you don't need to take the reciprocal in this case. You just multiply gradient with 2, you double the gradient. So acceleration is equal to twice of the gradient will give you the required acceleration. So you can do whatever suits you. Okay, that's what you will have to write everything here and you need to sketch. So one of the possible answer, and there are other options, because you don't need to take t square. Even you can plot root L graph as well, but it's another one, so I'm just not going into that detail. So there are other options as well. So one of the option to write the answer is, you can write something like this. So 2 acceleration will be 2 upon 1 upon gradient, because in this answer I took t square on y-axis and L on x-axis. You can flip it. If you flip, then these two will be changed. So these are L. This is L, sorry, L. Okay. Question number 12. Stokes law can be used to determine the magnitude of the viscous drag for a small spherical objects moving through a fluid. State one other condition that must be met in order for Stokes law to apply to the moving object. There are three main conditions for Stokes law. One is the sphere should be small. The second one is it should move with low speed, slow speed, or fluid flow should be laminar. It should not be turbulent, because if we have a turbulent flow, we cannot apply Stokes law. So low speed object should be moving with low speed, or flow of should be laminar, and sphere should be small, so we can apply Stokes law. So that's how you can write. I wrote two points, but you need to write just one, any one of these. A sphere falls through water at constant speed of 0.5 meter per second. Assess whether Stokes law can be applied to the falling sphere. You should include calculation in your answer. Okay, so we need to check whether we can apply Stokes law in this scenario or not. So these are the values given. So idea is, using these data, I am going to find the velocity as per the given data. I'm going to find the velocity, the theoretical velocity at which the ball supposed to, or sphere supposed to fall. I'm going to find the velocity, and then I will compare this velocity with the given velocity, whether it is same or different. So let's just figure out, because it is falling with a constant velocity. So constant velocity means all the forces acting on the object or spheres are balanced. That means it is falling. So when object falls through a fluid, or a sphere falls through a fluid, so we have weight acting down, and we have upthrust acting upward, and we have a drag force. That means at a constant speed, we say that drag plus upthrust should be the weight W, and drag, according to Stokes law, it is 6 pi eta RV. So 6 pi eta RV plus U is equal to mg, or you can rearrange for V. So V is equal to mg minus U divided by 6 pi eta r. You just substitute all the value and you find the value of V. Like you can do V is equal to m. M is the mass, and mass is, this is the mass. So 9.1 into 10 to the power minus 4 into G, 9.81, minus U. U is the upthrust, and upthrust is 1.1, 10 to the power 10 to the power minus 3, divided by 6 pi eta. Eta is the viscosity, which is 8.9, 10 to the power minus 4, and r is the radius, and we are given diameter, so divided by 2. That means 3 into 10 to the power minus 3. So you just use your calculator and put the numbers in there and find the velocity. So you will find the velocity as 154.9 meter second inverse, which is of course not equal to 0.5. So as per given data, theoretically the sphere is supposed to fall with the constant velocity of 155 around, but it is falling 0.5. So of course we cannot apply Stokes law, can't be applied. So you need to write this statement. Okay. Question number 13. A book of length L and weight W is positioned on a shelf as shown. Okay, center of gravity. What is state what is meant by center of gravity? So center of gravity is the point where weight of an object is appears to act. A most typical definition. You just memorize this. You can write everywhere whenever they ask center of gravity. So center of gravity is the position where weight of the object appears to act. So that's how you can write. There are contact forces at the two positions where the book touches the shelf. The book is moved a distance x to the right as shown. Okay. The magnitude of the contact force R varies with x. Sketch on the axis below the variation of R with x between 0 and L by 2. You should mark the maximum value of R on to the axis. Now if you see the situation of balancing an object between 2 points, let's suppose you have something, maybe you can say a rod or whatever you have here, a block, something, and you put a pivot at both edges. These are two pivots. So you know that you have two contact forces acting, let's suppose R1, initially I'm calling R1 because of the reaction, and R2 initially, suppose R2. And then we have a center of gravity acting. So at center of gravity, we have a weight acting. Clearly, if pivot are at equidistance, meaning this distance and this distance is same, equal. That means both reaction forces will be same. So R1 will be equal to R2. So you say that 2R is equal to W. That means one reaction force R is countering half of the weight. So R is equal to W by 2. And this is the minimum force of R. Minimum force, because if this is the position at the edge, so R1, this is the minimum position. Minimum value of R. Now what if I say, what if you just visualize, you shift any one of the pivot closer to the W or closer to the center of gravity, meaning you bring this pivot here. So what happened? Just try to visualize. What happened with R? It should increase or decrease? Of course, the R will decrease. R will decrease. Okay, and then if the pivot is exactly here, and you just remove this, so it will be balanced, and that at that moment contact force R will be equal to W. So W will be the maximum force, maximum reaction force that can act on the scenario. So on this axis, the minimum force is W by 2. You can mark here W by 2. This is the minimum one, but it's because it cannot be zero. It cannot be zero. In this case, in this particular case, because we always have some value of R, it is in contact, so we cannot have a zero value for as a minimum value. So we have minimum value of W2 and maximum value will be at equidistance. So you can say W here, this is W, this is maximum value. So, and you know that, so when do we have a maximum value of contact force, which is R equal to W? When this center of gravity comes here, and this length, which is L by 2, will be there. That means at L by 2 we have maximum force, and then at when we have x equal to 0, that means we have this point. But another important point, when you draw the join the graph, so it is not a straight line, it is slightly curved, something like this. Okay, so don't draw yes, so it is a curved line, it is a concave curve. The reason is contact force is just not directly proportional to the length L or L by 2. Okay, so that's something that you need to remember about that. Okay, explain why the book will not remains on the shelf if x is more than half or more than L by 2. Meaning, if you see the diagram, if you x is more than L by 2, so the book weight will be here, because the book, something like this. Oh, yeah, something like this. So weight will be acting something like down. So weight is not passing through the shelf, and this weight will cause a clockwise movement. which is a net moment. Due to this net moment, the book will fall. So you will say that the weight will no longer act on the shelf. It is beyond the shelf, which cause a clockwise net moment. When concrete is placed under stress, cracks may form. Scientists are investigating ways to prevent cracks from spreading through a concrete. One way to do this is by adding very small capsules containing glue to concrete mix. As the crack spreads through the concrete, some capsules break, releasing glue, which fills the crack as shown. So these are the capsules. When crack reaches a capsule, it's break and glue comes out and fill the gap. Two samples of concrete of identical size were placed under stress. Sample A consists of concrete only. Sample B consists of concrete with capsule containing glue. The stress strain graph of the samples up to the maximum stress before fractures are shown. Explain how adding capsules containing glue changes the properties of the concrete. 6-mark question. So here you see we have two samples. The dash is a sample A and solid line is sample B. Clearly you see that for a small stress, like something like here, for a small amount of stress, both the concrete sample A, sample B are behaving exactly same. There's not much difference between the behavior of the two. But as the stress starts increasing from that particular value, you see that the graph of the sample B, which is solid one containing glue, graph of the sample B starts steeping, more steep there. So gradient is increasing. Gradient increasing means sample B is stiffer, becomes stiff than sample A. That means B can withstand against large amount of force than as compared to sample A. So as the stress increases, sample B graph is showing that it becomes steep, so that it's more stiff. Moreover, stress strain graph, so we have large amount of area under the graph. So large amount of area under the graph showing that material B can absorb large amount of energy before breaking. So it is even tougher than sample A. So B is tougher because large amount of energy. It can have large deformation. Sorry, large amount of energy absorb, and it's all because of breaking capsule and filling this gap. So that's what you need to include every point about first behavior is steepness, stiffness, high strength, and then large amount of energy, large area. Question number 15. A ball falls through a vertical height of 0.6 meter before bouncing at point A on a ramp as shown. So this is a ball falling down and bouncing in this direction with 70-degree angle. Show that velocity of the ball immediately before the bounce is about 3 meters per second. Clearly a ball is falling freely. So the idea is gravitational potential energy is converting into kinetic energy. So it's just for your understanding, you say that half mv squared should be equal to mgh. Gets cancelled, so v is equal to 2gh root. This is the equation that you can use directly. So you say that v is equal to 2gh. That means 2 times of 9.81 times of 0.6 is square root. So v would be equal to 3.43 or 3.4 meter second inverse. This is the velocity. Kinetic energy is conserved as the ball bounces off the ramp. The ball bounces at an angle of 70 degrees to the vertical. State expressions for the horizontal and vertical components of velocity of the ball immediately after the bounce. Horizontal component and the vertical component. So we need to see the diagram. So let's just go back. This is diagram. Now you see what is happening here. This is the direction of the velocity v, and clearly this is the tail of the vector, this is the head. And if I ask you to find the component of this v, so you will find the horizontal component something like this. This is the horizontal component in that direction, and this one is the vertical component. Clearly this one is the adjacent component, and this one is opposite component, opposite to the 70 degree. So the horizontal component VH will be equal to 3.4, which is the velocity v that we found in previous part, 3.4 sine of 70, and v and vertical component acting upward, so VV would be equal to 3.4 cos 70. So these are the expression for the velocity, 3.4 sine 70 and 3.4 cos 3.4 cos 70, yes, vertical one. So that's how these components are. Point A is 0.86 meter vertically above the ground and 1.3 meter horizontally from the end. So 1.3 and 0.86 where the ball is bouncing at the ramp. Deduce whether the ball will bounce a second time on the ramp or not. Okay, so the idea is, you know that the ball is bouncing, so it is possible that the ball bounce and it bounce something here, or maybe goes there, or maybe the ball bounce directly something like this. That's what we need to deduce, whether we have a one more bounce on the on the ramp or not. And the idea is we need to use these information to figure out. The easiest way in my opinion is if we can figure out horizontal distance traveled by the ball. Horizontal distance traveled by the ball, meaning suppose this distance, or maybe this distance. But if we figure out horizontal distance, let's suppose s, and if this s is less than 1.23, so we will say that indeed the ball will bounce. And if the horizontal distance that we found is greater than 1.23, so we will say of course there will be no second bounce, it will bounce after the ramp. So we compare the horizontal distance. So that's the idea behind the deducing the condition. And how do we find the distance? It's all about projectile. So remember, for horizontal distance we will have to use s is equal to ut, and s is the distance need to be found, u is the horizontal velocity, which is horizontal velocity we found in the previous part, 3.4 sine 70. And t, we don't have t. That means before finding horizontal distance we need to work out for for time. And how do we find the time? We are going to use this vertical height, and this vertical height we can find the time, and this time can be used here in this equation, and then we will compare. So we have given a vertical height, and from vertical height we can find the time. And the way is you will use s is equal to ut plus half at squared. And now this s is a vertical height, and this vertical height is below the point of projection. It is below. So this is our origin. This is my x-axis, this is my y-axis. So this is lower or below the origin. So for the sake of sign convention, because my displacement of the ball is below the origin, so this s should be negative. So I will take this height as negative 0. Minus 0.86 equals u is the vertical velocity at the point of bounce, which is 3.4 cos of 70 into t. We need to find t, and plus half a is acceleration, and because we are considering the whole motion of the projectile, so a will be minus 9.81 into t square. Clearly, if you rearrange everything, so you have a quadratic equation in terms of t square, and if you rearrange, then you can rewrite this equation as 4.91 t squared minus 1.1 t minus 1.1, not the t, minus 1.16 t, and 1.16 is the value of this 3.4 cos 70, 1.16 into t, and then minus 0.86 equal to 0. This is quadratic equation in terms of t, and you can use quadratic formula, you can use your calculator to find value of t. One t will be negative, that you can discard, don't need to find, don't need to waste the time. The other time will be positive, that you need to figure out. So use your quadratic formula. So once you use your quadratic formula, I'm just writing here one form. So t would be equal to minus b. So minus b is minus 1.1 plus minus, it's not 1.1, 1.16, because it is b, 1.16, plus minus 1.16 whole squared, minus is also there, minus 4ac. A is 4.91 and c is 0.86. 0.86, this is whole in one root, divided by 2a, and 2 is 4.91, or you can use direct calculator. So t would be equal to around 0.553, 0.55 second. This is the time, and then this time you can use to figure out the horizontal distance. So s is equal to 3.4 sine 70, which is 3.19, or 3.4 sine 70 times 0.55. So s will be equal to 1.77 meter. Clearly, the found horizontal distance is greater than 1.3, so which is 1.77 is greater than 1.23. That means no, it will not bounce. So it will not bounce. It lands on the ground. Thank you very much. I hope you understand. Have a nice time.